SQL injections are one of the oldest tricks in the books when it comes to web security, but they are arguably one of the most dangerous techniques as well, since their impact is very high. You are going to see how hackers exploit SQL injections and use a tool called SQLmap to steal and sell your data on the dark web. Let's start with the foundations. To get to the world of SQL injections, we must first start by understanding how databases are set up. Let's keep it simple. When a user is trying to access a website, what they are doing essentially is communicating with the web server. You have probably heard of Apache and Nginx. These are examples of web servers. Behind that web server is generally a database that can't be accessed directly. So when a user tries to log in, for example, the user goes to the interface, enters a username and password, and the server is the one to communicate with the database. The server then sends the user back the response. This database stores your user information, credit card information, and other stuff, so it's going to be the target of the hacker to try and steal from by injecting some malicious payload. The database is generally going to be an SQL database, so in the hacking world, we call this sort of attack SQL injection. Let's start by explaining briefly how SQL works before going to SQL injections. Let's imagine that our user has a search bar on a blog website. They enter a phrase that they want to search and then get back the results from the database. What actually happened behind the scenes is that the user sent the information they wanted to the server, and then the server queried the database using roughly this query. Select asterisk from articles where articles like %symbol, infosec mastery, %symbol. The database then checks all the entries it has. If any of the entries contain that specific string, the database returns a list of items to the server. Finally, the user will see all the articles on their browser. Now, an SQL injection is where we inject some payload in that field to either extract too much information that the users are not supposed to see or bypass some sort of authentication. For example, in authentication, when you try to log in, the request should look something like this. So if a user enters the correct credentials, the database will reply to the server, "Hey, one of the rows in my users tables matches with that combination." So the server lets the user enter the application successfully. On the other hand, if incorrect credentials were entered, the database will tell the server, "Hey, I don't have any rows that match that combination at all." But when a hacker comes into play, they will change the logic of the SQL statement itself. For example, if the hacker enters the phrase apostrophe, or 1 equals 1, with a missing apostrophe in the end, in both the username and password fields. The server will send this request to the database, and the database will mistakenly consider those apostrophe symbols as part of the request. According to this statement, the database will check if any of the rows have a username that's empty or has a 1 equals 1 condition, and at the same time, if that same row has an empty password and has a 1 equals 1 condition. Obviously, none of the rows in the database should have an empty username and passwords, but that's when the 1 equals 1 comes into play. 1 equals 1 is an always true statement, which means when the database checks each row, the row will have a true condition. This causes a problem because when the database replies to the server, it will say, "Hey, I found multiple entries for the thing you asked me for." So the server will say, "Well, there is more than one entry, which is not 0, so I'll let this guy come in." This allows the hacker to enter the application without needing to have valid credentials. Now let me help you understand the vulnerability even better with this example. In front of us, we have this application that gives us the first name and the surname of the user when we enter their ID. So if we enter the ID one, we get the first name admin and the surname admin. But how can I make sure there is an SQL database server in the back? And how do we know the database is vulnerable to SQL injections? Well, it's pretty simple. We just have to enter the apostrophe symbol and see if any errors appear. Evidently, an error is raised because the SQL statement is no longer understandable by the database server, so we proceed with our attack. As I explained before, we are communicating with the server by sending the value of the ID that we want. The server makes an SQL query to the database, which should look something like this. So, since we are the hackers, we are going to manipulate the statement. We add an apostrophe and then add or 1 equals 1. This will trick the database by making it look for the first name and the surname of the users that have an empty ID or have a true condition. And since it's a true condition, it will return everyone. We want to take this a bit further. We do not want to just find all the first names. We actually want to exfiltrate the entire database, including all the tables, all the passwords, all the sensitive information. So instead of doing this manually, we are going to use a famous tool called SQLmap, which automates all the hassle for us. SQLmap is a free tool that can be used on Linux, and I believe it can be used on Windows as well. Anyways, let's get started with SQLmap. We are going to give SQLmap our vulnerable URL, basically saying, hey, this page and these parameters are vulnerable to SQL injection. I want you to test them. And then we specify to the tool that the SQL injection vulnerability is in the ID parameter. Finally, we just add a header, which will be the session cookie. The session cookie may not be necessary depending on your situation, but in my case, I need it. I'll just add one last parameter to remove the previous results of the scan because I already did a scan on this application, so I want you to see what SQLmap does in the initial scan. After that, we just launch SQLmap and let the magic happen. As you see, from the get-go, it tells us that the ID parameter might be injectable, and the database system might be mysql, which is a popular SQL database management system. Here, SQLmap confirms that the database is indeed mysql and asks us if we would like to continue to check if it's maybe a different system. I just refuse and keep the scan going, giving confidence in SQLmap's detection. As you can see among the results, the tool confirms to us on different occasions that the ID parameter is indeed vulnerable, so I tell it to stop the scan and to not look for any other vulnerable parameters since just one parameter can get the job done. Now, since that is completed, we are going to proceed with the exfiltration for the database. We rerun SQLmap another time and add a new parameter, which is tac-tac-dbs, which will exfiltrate the names of all the databases that exist on the database server. In the results, we have two databases named DVWA and Information Schema. So we want to dig deeper into DVWA because it is the one to contain sensitive information. So we rerun SQLmap, and now we change the tac-tac-dbs parameter with tac-d-dvwa to specify that we are only interested in the DVWA database. Finally, we add a new parameter, tac-tac-tables, and run again. In the results, we have two tables, guestbook, and users. If I were you, I would be interested in the users. So we rerun SQLmap one last time. This time, we swap the tac-tac tables with tac-t users and add a final parameter, tac-tac-dump. In the results, the tool tells us that inside the users table, it found a password column and recognized that the passwords are hashed. So I am going to tell the tool to try and crack these passwords, and we'll tell it to use the default password list that it has. Slowly but surely, the tool is able to crack every password one by one. And as you can see, we have finally dumped the entire database. We have all the information about the users. This is where you would usually find sensitive information or credit card information and so on. And since the passwords are cracked now, we can take, for example, the admin user. We see that his password is just the word password and use it to log into the application. And that, my friend, is how to hack a website with SQL injections. If you were pleased with this video, I am sure you will like this other hacking video where I use Metasploit and Nmap to take over an entire machine. I'm sure that you will learn something new from that video as well.